So this is the day we're having. Cloudy, like always. But how much is 1700 watts making for the Powerwall? We got 182, 89, and 108. This is the most that I've seen go into this bank so far. Volts are pretty low. It's only 52.8 volts. So I shut the system off. I'm gonna let it charge up. This one says 53 volts. But yeah, everything's working good. This guy here, I've got 14 hours on him now. I brought it to work, ran it all day long. I ran a Sawzall off it for a little bit, 10 or 12 amp Sawzall. You couldn't jam it very hard or it would trip it. What else did I run off this out? And when I wasn't running the Sawzall, we ran the radio and charged the radio all day. So it was a light load most of the time. But yeah, I'm getting my hours on it within the 2-week time period. And it's been doing really good. And it's actually getting quieter as I use it, so that's nice. I'm very happy I bought this, but anyways, thanks for watching, guys. Well, we hit 200 watts on this one. This one's at about 100. So 300, we're a little over 400 watts now. Guess it's getting a little bit brighter out. It's awesome. Might almost get this bank charged today if we can keep putting 400 watts into it. Probably not, but it'll get up there. If the sun would come out, we should be getting around like 400 watts each, but we'll see. Anyways, thanks for watching. So I've decided to reassemble this pack. I'm very unhappy with it. As you can see, not very pretty. I was just blobbing solder on the side because I don't have anything big enough to get this thing hot enough to actually solder it, so it looks even worse. But I'm going to cut all these wires off. I'm going to separate all these all over again, and this time I'm going to put these into parallel packs of 4, 4, and 4, and I'm going to use pop rivets with washers on both sides to connect the cells together. And then I'll be able to attach and possibly solder onto the pop rivet. Yeah, because this isn't working very well. I'm getting some cells that are not connected, and then the one cell will be low and the other cell will be high, and then they'll connect to each other and dump a bunch of power into the other battery. Same thing on this side. So I'm gonna get to it. Okay, so disconnected all the cells, and I'm going to be using these different pop rivets and these very small washers, and I'm going to start pop riveting them together. See how that goes. And just like that, sun's gone. And what have we made today? Today was actually pretty good for solar for what I'm used to in the winter here. We've got 13 amp hours here. We've got, where's the amp hours there? 7 amp hours on the top one and 7.4 amp hours on this one. We're getting almost no power now, almost at 62 volts. So we got up there. We did all right. We're probably about 80% full, maybe 70%, something like that. Or less, I don't know. Because that's only 13 amp hours, 7 amp hours, and 7 amp hours. That's not even close, because this is let's see, 5 amp hours each, so that is what is this now? 5, so that's 15 amp hours, 15, 20, 25, 30, 35, 40, 45. So there's 45 amp hours. If these are 5 amps each, they're actually more. So I'm being very conservative by saying it is a 45 amp hour power wall. It's probably closer to about 55, something like that. And we've only put in 13 amp hours plus 7, 14. So we've only put 27 amp hours in today into this battery bank. We're at 61.8 volts. Awesome. And back to my other project. Alright, so this is what I got done inside. Let's see if we can get real close into here. Okay, so we got the pop rivets going through, pinching the cables and everything in here together. And now I'm going to go over it with the soldering iron and solder everything together, solder right to those pop rivets, and make everything extremely sturdy. And I'm going to, by putting solder over the wires, it'll increase how many amps I can pull through these wires. Not by a lot, but it'll be a little bit. And we got my 35-ish amp hour pack here. Something around 35 amp hours. I got to do a capacity test on it. Just got to put balance wires on it and put my Anderson cable on it. This big guy here. And we'll be set. Okay, so I got my setup, my test setup already. I got all the connections done. So that is now very solidly connected. Got my balance leads on. Everything's going to my AP640 balance charger. These are the cells. One bank of cells was really high because when I was using it before, I drained it, and I guess I moved it around and some of the cells disconnected, and then I charged it. So when I was hooking this back up and connecting cells together, I could see that there was current flowing from one cell to the other. I shouldn't have that problem anymore, I'm hoping. So we'll see. I'm gonna let this balance charge. Here's my power supply that I use all the time for this thing. Works really good. And then this is what I've only put in. I've only put 2 amp hours in because it was pretty much fully charged when I started. And then yeah, I'm gonna do a discharge test. I'm gonna take it to work tomorrow. Hopefully, I want to put this in an ammo box, have everything fit, spray foam around it so it can't move. Mount this to the side of the ammo box because I think it's too big to go inside, which is fine. And then I can run my sawzalls, my skill saws, anything that I need to for like a quick repair, get in and out, that sort of deal. Yeah, so I've already tested this with a crappier way of connecting these batteries, and it ran a skill saw no problem. So that's the big worm drive skill saws too. So this new improved way should actually get me more power as well. Anyways, thanks for watching, guys. Hope you guys enjoyed the video. Okay, we're recording. Yes, I'm in my pajamas just because it's late. Going to bed fairly soon after this, but the battery is finally charged. This, if you guys can see it, I'm not sure. Move this down for a second. This is a 35, between 30 and 40 amp hours. I'm not exactly sure. I got to do a capacity test, but this has let's see, 1, 2, 3, 4, 7, 8, 9, 10, 11, 12. This has 24 cells. It's a 3S configuration, so that'll give you how many cells it's got in it. I have it hooked up to an eliminator 3000 watt modified sine wave inverter. We're going to try running an angle grinder, a compressor, and a work light all at the same time. That's pretty much the sum of what I have in my garage to run today. Usually what I'll be using this for is a skill saw, worm drive skill saw at work, or a sawzall, which I don't have here. And I'm not sure if you can see this. Let me put this lower. The form factor of these two is smaller than this generator. And this is only a 1000 watt generator. This generator can run everything I'll be running here tonight, but it can only run one at a time if it's which it involves this compressor. It can run the light and the grinder, but it can't run anything more than if the compressor's on. So this will be outputting more power than this can. I also have my lithium power it. This is a battery generator. They call it a generator because you can hook a solar panel up to it. But that's 500 watts. It can run the light only, cannot run the grinder, and can't run the compressor. And here I have my homemade lithium polymer 120 amp hour MO can. It's got a 300 watt low frequency inverter. This can run the light, it can run the grinder, but it's got to be separately. It can run them both. It can't run the compressor though. The compressor takes too much. So just going to see if we can run all three of these at the same time and see how well it works. Let's get to it. Power it up. It says 12.7 volts, but that voltmeter is off. It's actually 12.55. That's what I got to charge to. And get these cords in. I'm going to shut the compressor off so I can just turn it on and it'll go. Okay, we'll start with the light. 12.7 volts. You want a work light when working. There we go. Instantly went to 12.6 volts. You got a work light going now. Okay, so I got my compressor in the background. This will act kind of like a low power skill saw. This definitely doesn't take as much power as a skill saw, but that's okay. I got my work light going in the background. Got my compressor going. Okay, we're pulling over 1000 watts. We're at 12.1 volts. And now I want to run my skill saw. We're at 1.6 kilowatts we're pulling a second ago. Oh. That was weird. Interesting. That's something funny. Like it was shutting down. Ah, cell phone battery went dead. Forgot to charge it again, but I'm not sure how much you guys missed, but I'm going to be plugging this into the battery. I want to see what the cells are doing. This will tell me exactly what's going on. Minus is on this side, so I think I'll plug it in this way. Okay, so now if I turn this battery on its edge, I can see 12.1 volts. Cell 1 is 4.07. Cell 2, 4.01, cell 3, 4.04. We're nice and close, everything seems okay. The problem is this inverter turns off at way too high of a voltage. So I'm going to try the angle grinder with just the light. No problem. Now I'm going to go with the compressor. And then the angle grinder. It kicks out for a second, turns right back on. Now I'm going to use both these at the same time, see what happens. Working now. So there is a limit, obviously. The biggest problem I see is that this pack is at 12 volts And this likes to shut down at 11 volts. So this is not the ideal inverter. The ideal inverter would be one that's shut off at 9 volts. Which is unfortunate. But it is still going to be very useful. So whenever we use this, I always use, like if I unplug it obviously, compressor works. We're pulling 1,120 watts, cell 1, 3.93, cell 2, 3.79, cell 3, 3.89. So I'm hoping that all the cells are connected this time because there's a lot of cells in parallel. I'll be having to check that later, but let's see what they say now with a lot less load. Got 3.97, 3.90, and 3.95. That is all pretty close. It is pretty close. The positioning, I can actually show you guys closer up. The positioning of my balance wires on this pack. Oh, let's get that out of the way for you guys. The positioning on that pack could also be when it's a heavy load, why it's some cells are a lot less than others. I might not, I have them on like the bus bars instead of the battery terminals directly, so that could give an inaccurate reading. But 12 volts, still with the 300 watt light on. 11.9 volts it says on that meter. And we'll try the compressor stirred up one more time. Shut off because it's full, so we got to actually. Sorry, I should have warned you guys. That was pretty loud. All right, here we go again. A slight beep because it went low in volts for just a little bit, pulling over 1,000 watts again, 1,130 watts this time. Yeah, seems to work real good. And with no load draw, we're sitting at, inverter says 12 volts, battery says 11.9. Okay, so that's good. Working just fine. Thanks for watching, guys. And actually, I just wanted to show you guys something. This is the battery when it's not plugged in. I would say it weighs about 10-15 pounds. Those are my new solder leads. Here you got the voltmeter. Let this cycle all the way through once. The cells they're very well balanced actually. They're pretty good. When I left, the one cell, when I took it off the charger, it was at one was 4.20, one was 4.17, the other one was at 4.17. So it's done very well. Yeah, time will tell if this new way of hooking up these leads are any good. But so far it's looking pretty good. My only problem here is the shut-off voltage of this inverter. And this is what I am using. This is quite old. I've used this on the construction site a lot at work. I like it. If you only need a modified sine wave inverter, you get these on sale at Canadian Tire. They're really good inverters. I like it. This thing's been through a heck of a lot of abuse. Overloaded like crazy all the time, but it's never failed me. It works well. There is something floating in it though, but it could be just some dust or there's something from the job site. So I wanted to give a good idea on how much power this has in comparison. I was going to compare it to my LiPo box. This thing has more usable power. This is 120 amp hours. The one I just showed you is 35. But here's the compressor. This is only a 300 watt inverter, but it's a low frequency, so it'll try. It turned over, but not enough. So this can't run it. This will charge all my DeWalt batteries and stuff at work, or run my bar fridge at work, stuff like that. Won't run that. It'll run the work light, no problem. It actually even runs the grinder, which is pretty power intensive. Let's see here. Not bad for a 300 watt inverter. Then we got the other option I have, or that everybody has, is this Power It 500 watt inverter. There, the display is on. We're going to turn the inverter on. One thing this Power It can't do, it doesn't like the surge of this grinder, so it doesn't run it. It tries, but it can't run it. What it can run very well is this light, and it runs it for a very long time. No problem. The fans turn on the unit under load. It's a very good unit. I like it a lot. Not doing my little fireplace. Okay, so that's that. Then I'm also comparing it to my Black Max inverter generator, 1000 watts. It's got a decent surge, and we're actually going to start that and compare it. It's going to be real short because we're in the garage. So let's do that. I don't know what it sounds like on camera, but that has gotten a lot quieter. A lot. It's on eco mode, so it's just quieted down. Plug the light in. It's only got one plug for a reason, because usually it can only run one decent size load at a time. When using a compressor, you have to turn it to eco mode off. So we're going to turn it off and turn the compressor on. That's eco mode off. And the compressor started. That's eco mode back on. And here's the angle grinder. This is with eco mode on. And here it is full power, eco mode on. And that is that. So, that gives you a nice little comparison of my power sources that I've been using and why I put this little setup together here. It can run way more. It's a very small, very small arrangement. I'm going to put this, I've got another ammo box just like this one here. I'm going to put the 3000 watt inverter on the side just like that. I'm going to put the batteries inside there. I'm going to foam around them. I could put a charge controller because there's lots of room in there. And yeah, I'm going to have a sweet little, this will pretty much, this kind of blows anything out of the water for like large inverter size, because this is 3000 watts. It's not going to run for a long time obviously, but you can run huge items off of it, and it's going to be quite light, and that's what I like about it. Anyways, thanks for watching guys. Hope you enjoyed the video. Give you one more look at the power wall. We got some charge today. Sorry, I got you guys on the tripod. Let's see if we can get the voltage. We got 59 volts. we're doing good. Hope you guys enjoy the video. Alright, I don't have much time. I found out what the rattling was. You can see that I may have been a bit rough on it. Anyways, here's the inside. And I found out this is fused for 400 amps. That's crazy. Got 200 amps on